Okay, so the very first thing that we're going to be doing today is we're going to learn a trigonometry formula for finding the area of a triangle. And you probably remember, or maybe not, the geometry formula for finding the area of a triangle. And I have a lovely picture of a triangle here. And we remember that area equals 1/2 times the base times the height. And so down here is the base, and here is the height. But the question is there a formula that you can use if you don't know the height? And the answer to that is yes, and it involves trigonometry. Now, if you look at this triangle right here, and we've got sides A, B, and C all labeled here. I want you to consider something. If I don't know H, but I need to use it in the formula, I can use trigonometry to get that. Would you agree, if you just look at this right triangle right here, just this guy, would you agree that the sine of A equals H over C? That's opposite over the hypotenuse. We can agree on that? So what if I take both sides and multiply by C? And so then I get H equals C sine A. All right? So now if I go back to my formula, which is area equals 1/2 base times height, and I replace the height with C sine A, I actually get 1/2 BC sine A. Now, I can look at this with side B as the base. I can look at it with side C as the base, or side A as the base. And in each of those other cases, H is going to be a different H. So let me just show you, for example here, let me get a little ruler out. And if you look at, let's turn the paper so it's like this. So if side A is your base, would you agree your H is going to be right here? It's a different H, but there it is. That's your perpendicular height. That's what makes your H in the formula, area equals 1/2 base times height. So what we can do is then there are 3 formulas. So 3 formulas for area. Now, all we've done in each of these formulas, they're the same, except that the rotation of which sides are used is varied. Keep in mind, if B and C are right, sides B and C are here, angle A is what you're taking the sine of. So if A and C are here, B is the angle. A and B are here, the third one is C, that's your angle. So it's easy to memorize because all you got to remember is that whatever is here, the other 2 are here. All right? And so you're just going to use whichever one most appropriately fits your stuff. So here's what I've got. I have got a triangle down here, and it says, what is the area of triangle ABC to the nearest 1/10 of a mile? So I have these 2 sides, and would you agree, this side here, since it's across from angle B, that's side B. Since this is across from angle C, this is side C, and I happen to know angle A. Okay? So what I can do is use the version that goes like this. Area equals 1/2 BC sine A. So 1/2, B is 5, C is 10, and then I have sine 31 degrees. And we just need our calculator. So when you're making sure you're in degrees, I just checked and I am in degrees. So 0.5 times 5 times 10 times sine 31. And I get 12 point to the nearest tenth, 12.9. And that would be miles squared. All right, because your units for area are always square units. Okay, not too bad. Let's turn the page over here. And actually, go down to the bottom, because we've got some room here at the bottom of the page. I'm going to show you the coolest thing. Would you agree, no matter which of these three formulas I'm going to use, the area of the triangle is the same? So these three formulas are the same. It's just what pieces, parts you're going to use. So we agree 1/2 BC sine A equals 1/2 AC sine B equals 1/2 AB sine C. Now, let's do this. I have an equation. It just has three parts, right? Can do whatever I want to each side as long as I do the same thing. So let me do this. Let's divide each of the three parts by 1/2 ABC. And I'm going to make a new formula out of this. So there I go. I did that. Let's cancel. So the 1/2 and the 1/2 cancel. The B and the B and the C and the C. And what I have left is sine A over A. Agree? Go to the next one. The 1/2 and the 1/2, the A and the A and the C and the C cancel. And I have sine B over B. And if I go to the third one, the 1/2 and the 1/2, the A and the A, the B and the B cancel, and I have sine C over C. And now, you see, I have a brand new equation. And this equation is called the law of sines. And would you agree, this looks really easy to remember? Yes, it's very easy. This is so cool because yesterday in your homework, you were using trigonometry in order to solve for the side lengths and the angle measures of right triangles, right? Well, here's what this allows you to do. Solve for the side lengths and the angle measure of any triangle, not just a right triangle. And the way you're going to do this is using the law of sines. And so, finding the side of a triangle, we're going to do this. I don't know what this thing is going to look like, so I'm going to find a nice little triangle to put up here. This looks like a good one. Oh, there we go, a nice little triangle. So this is PQR, and it says the measure of angle R is 39 degrees, so I'll call this guy R. And we'll write in here 39. And the measure of angle Q is 32, so I'll call this guy Q. And this is 32. And it said, that means, you know, this has to be P then, right? And it says PQ, which is this guy right here, is 40. All right? So that's what we're given. Now, would you also agree, since this is across from angle R, this happens to be little r? Little r. Okay, and it says, what is RQ? That's right here, and would you agree, since it's across from angle P, this is little p? Okay? So here's what we've got. We're going to do law of sines, but we're going to do it with P, Q, and R. So sine P over P equals sine Q over Q equals sine R over R. And we're going to fill in what we know. So we don't know sine of P. So sine of P. But do we know little p? No, we don't. We're going to leave that guy alone. Sine of Q. Yes, that's sine of 32 degrees. And little q, we don't know. And we have sine of R. Yes, we know. So sine of 39 degrees over little r, which is 40. Fair enough? We can find all the rest from here. All right? Would you agree we can find P over here by doing 180 minus 39 minus 32, right? And I get 109. So P is 109. So RQ here, this is little p. So I don't even need this middle part because I'm not asked anything about that. So would you agree I have sine of 109 equals sine of 39 divided by 40? Fair enough? Okay. Cross multiply. So P sine 39 equals 40 sine 109. Divide both sides by sine 39. Okay. Calculator. 40 times parentheses sine 109 divided by sine 39. 60.1. Make sense? .1 centimeters. Sound good? That's all there is to this. Let's do one where we find an angle measure. So down here at the bottom, I have triangle RST. All right? And I don't know what triangle RST looks like, but it's got an angle that's obtuse here, so I'm going to call this R, and this is 110. And so one of these is T and one of these is S. So across from R is 9, and across from T is 7. Agree so far? And what do we need? Measure of angle S. So sine S, and this right here is T, R, and S. So sine S over S equals sine R over 7 equals.
Wouldn't it be sine 110?
Oops, you're right. Let's put 110 right in there because we know it. Sine T over, whoops, this is 9. And this one's 7. Okay. I cannot go right away to sine S because I know neither of these. But you know what I can figure out is T. And would you agree, if I can find t, I can find s by doing 180 minus r minus t, right? So let's do that cross multiply. So 7 sine 110 equals 9 sine t. Divide both sides by 9. And then we'll say t equals inverse sine of whatever that is. So let's figure out what that is first of all. So 7 sine 110 divided by 9, and that gives us 0.7309. I'm going to show you a lovely little trick that your calculator does. I need the inverse sine of that. So second inverse sine, I want this last thing that was just in my calculator, right? Go down here and you see this little, the negative key. Second, that key will bring up your last answer, so it pulls it right in there. Close your parenthesis, and I get 47 degrees, okay? So t equals 47 degrees. So this is 47, and s equals 180 minus 47 minus 110. And I get 23 degrees. There we go.
Why did you do the inverse sign for that one, but not for the other one? Is there a reason?
Because what I was trying to find was the angle measure. In here, I'm trying to find a side length. All right. Got a lovely little story problem right here. Let's get us nice and straightened out here. All right. A surveyor locates points A and B at the same elevation and measures distance and angles as pictured. All right. And it says, what is BC, the distance from B to the summit? All right. Now, this is interesting because all I know is this distance right here is 3950. So the triangle that I am looking at, whoops, is this. All right? That's the triangle I'm looking at. So this is A, this is B, this is C. Now, if this is 31, do we know what this is? How do we know? Do you remember what kind of angles these are?
180 minus.
This is 180 minus 31. And it gives us 149. All right, so we're trying to find this. Now, in our diagram, this right here is side C, this right here is side A, and this right here is side B. What we are trying to find is side A. So, can we figure out angle C? Is that a possibility from what we have? Yeah, okay. So angle C, 180 minus 18 minus 149 equals 13 degrees. So I have side C right here. So how about this? We will do sine C over C. The other one I need is little sine A, or little side A. So I'm going to do sine A over A. All right, so sine C is sine 13 degrees over 3950 equals sine 18 degrees over little a. Cross multiply, and we get 3950 sine 18 equals a sine 13 degrees. Divide both sides by sine 13 degrees, and you're going to get a equals 3950 sine 18 divided by sine 13. And we just need to put this in our calculator. So 3950 times sine 18 divided by sine 13. And we get that this is 5,426 feet. Now, let's go ahead, and we've got the question, what is CD, the height of the mountain above points A and B? So now when you look at, you're looking at a different triangle here. We know what this is. In terms of this triangle, let's go to a new color. This is now side D. This over here is B that we're trying to find. C we don't know. Let me ask you, do we know this angle C up here? Can we find this? Yeah. How do we find this?
180
Minus 90, minus 31. All right, so 180 minus 90 minus 31 gives us, this is 59 degrees. All right, so that guy is 59 degrees, and this guy is 90 degrees here. So we could use, actually, law of sines, or because we actually have a right triangle, we could use the adjacent, the opposite, and the hypotenuse like we were doing the other day. We have options. What do you guys want to do?
This one.
This one? All right, let's see if we can do this one. So we are trying to find side B. So we're going to need angle B. So sine B over B. And the other one we can do actually is we'll do D. So sine D over D. And let's fill these in. So sine B is sine 31 degrees over B that we don't know equals sine 90 degrees over D, which we already figured out is 5,426 feet. So if we cross multiply, we have B sine 90 equals 5,426 sine 31. What's sine of 90? It is 1. All right, remember that from your unit circle. So B equals 5,426 sine 31 degrees. Let's get our calculator out.
Wait, wouldn't it be 59? Why isn't it 59 degrees?
Because we were using angle B, which is 31.
Oh, makes sense.
So this B is 2,795 feet.